Yeah, hello everyone. I'm happy to be here. My name is Günther Teufel. I'm a lead developer at Felgo, your partner for modern cross-platform development with Qt and QML. And yeah, I'm happy to welcome you to my talk about QML and C++ architecture best practices, how to develop scalable Qt Quick applications efficiently. Yeah, so at Felgo, we've been working a lot with Qt, especially also in the mobile sector for iOS and Android, where we also offer SDK with a lot of components that you can take advantage of. And yeah, especially on those platforms, it is really important to offer a great user experience, which is why we heavily rely on Qt Quick and QML, because it is extremely powerful for all of these use cases. And during our projects, of course, we learned a lot about how to best utilize it and yeah, what to look out for and how to set up your project to be scalable and can handle all of the things you want to do well. Yeah, let's dive into it. QML and C++, two very different languages. First of why was QML introduced, or why is it important? And the main thing is for UI-driven development. The user interface is extremely important, and QML offers a declarative language to build your UI, which is extremely flexible and powerful. You can add event-driven logic with the built-in JavaScript support, and yeah, it's really a charm to work with. In addition, QML offers near-native performance with the highly optimized QML engine and the Qt renderer. You also have the option of ahead-of-time compilation with Qt Quick compiler, and by default, Qt also does just-in-time compilation. So yeah, your QML code will be really performant, and for most of the use cases, it might not even warrant going further to C++, especially if it's just some user interface code gluing components together, because the additional step to go to C++ also requires some performance and some overhead. So it can make sense to stay in QML all the way, especially if you're using property bindings, for example, where Qt offers optimized bindings to make them really quick and fast on the QML engine. QML has many cool language concepts like item states. It offers the event-driven nature with signals that I already mentioned, and also property bindings. It's easy to learn, and it really reduces the amount of code compared to C++. It makes adding animations and effects very simple. Still offers great performance because all of the QML items are actually backed by C++ components. So the item tree that you build up in QML will be represented by highly performant C++ objects once it is built up in the QML scene. So yeah, really great choice, especially for user interface topics, but also not only for UI topics. If you look at Qt and the modules that Qt offers, be it multimedia, for example, and many other things, most of the things you can use, you have the option to either use the Qt C++ APIs or the Qt QML APIs, which offer you the same functionality just for the two languages. Yeah, so there's really no big disadvantage of using QML. So if we are developing Qt in Qt Quick, when should we actually move to C++ or stay at C++? And it's basically the right choice for data-intense operations. It is also type-safe and fully compiled. So for parts where stability and security are essential, it's really important, and of course better to rely on C++ than on QML. Also, some of the Qt C++ APIs might offer more features in C++ than they do in QML. So whenever you're limited or you want to do something special, you always have the option to jump to C++ and do your things there. When talking about the mobile platforms and the cross-platform development, from C++, you also have the option to go further and integrate Objective-C code or Java code for Android. So you can really use it as the main point for going away from QML and bridging to other languages. Also to integrate libraries, for example. So let's check out some of the architecture best practices for QML-driven applications. It starts really simple, actually, because QML is easy to use and very flexible. But the more you code, the bigger your project grows, the messier it can get. As already mentioned, QML might be used for far more than view code. There is also no type safeness, as said before, and then due to the flexibility, you aren't forced into a certain architecture or doing things a certain way. So it can get really hard to optimize, debug, and maintain your code in the long run. Some issues you might face include duplicate elements across different components, redundant functions, and JavaScript logic, which is spread out on many different views of your application. You can even end up with dirty application states where one component is not in sync with another. And also binding loops, which are a big indicator of something doing wrong also on the architecture, because if you're updating properties with the property bindings and expressions, and you run into a loop, there's probably some circular dependency that requires optimization. Let's look into it in a little bit more detail. QML is event-driven, and property bindings essentially manage the state. The signals when properties changes notify other components, and each of the property changes that also notify other components propagates through many items, and this forms a graph like you can see here. The problem is when you add many more components, many more property bindings, and each change notifies other components, which maybe does do some calculations and then also change some of the properties, which in turn also notifies again some other components. You won't be able to really track anymore what exactly is happening. And this is also like the breeding ground for property circular dependencies, so binding loops with properties. This drives the need for clean interfaces and a well-designed component structure, which, of course, also a good architecture can help you with. When looking at design patterns for application architectures, there's one golden rule, which is to keep the view code separate from the data that you're handling and processing. Examples of that are the MVC pattern, model view controller, or MVVM, model view model, or Flux, which is a pattern that is used by React. And all of these patterns can vary a lot depending on the technology and the language that you're using. Also, the terminology is often confusing regarding what is the model, the controller, the view. So it's really important to know that all of these things are, good to know, but you always have to see what's right for you and right for your project, for your language, for the technologies that you're working with. If you look at this pattern in regards of QML and C++, the two languages that we have with Qt, there's respective implementations in both C++ and QML. So you have a list model, which is based on QAbstract item model. You have a list view, which in C++ would be QList view. And you also have some controlling code, either in QML and JavaScript or in C++. And with the Qt Quick application, again, the controlling part is more on the QML side, which is why the graphic shows it like this here. And the pattern or MVC is not really about languages. That's also what this image shows here, because you can have your list model implemented in C++ and then use it in QML together with your QML list view, and it's not any issue. So the model view separation here really transcends any language boundaries. You can use it however you need to. The higher level architecture is basically up to you. Still, if we look at this in a broader sense for the higher level architecture, if we say, okay, here we have a list view and a list model, we usually have many different pages with different data that they show. And those list models and list views, for example, are used on individual pages in your application. And yeah, the QML and JavaScript logic handles your user input and controls the view. But it is not enough to just rely on this and then know, okay, I have model view separation in my app. I use the Qt list model and list view. I do not need to do anything more. That's not enough, because we also want, when looking at the big picture, separation of the business logic and the application data, basically the application state from the user interface as a whole. So not only a separation between a certain view and the data that it presents, but also a separation between all of the application data, all of the application state, and yeah, all of the user interface, regardless of which items the user interface might actually include or how many pages. How can this look like in QML? For example, you could introduce a global data model component, which covers the view state, the application state for your application. It controls and drives the application user interface, which in turn does not have any calculations anymore for processing all of the things. All of this logic and the data handling and the application state handling just moves to a different component. And yeah, then you can also, for example, have multiple pages connecting to the same data source and updating respectively without any inconsistencies. You can also very easily switch the whole user interface at a later point, because all of the application state and all of the data in your application is still managed separately in an own component that does not require a UI. Yeah, how can it look in an actual live demo? Let's jump right in. I have a small example app here with a data model and a view. In this case, it's a navigation with a navigation item and a navigation stack and a to-do list page. Those components are just some very easy to use and simple components from the Felgo SDK. For example, the navigation stack is a styled stack view, which offers transitions for mobile styled items like on iOS or on Android. You can also see how it looks on Android or see how it looks on iOS. For example, on iOS, we would have a tab navigation instead of a navigation drawer on Android. But this is all. Some details about the items. The important thing is that the data model is its own thing. And if we have a look into the to-do list page, which is the list page that we just saw before, here we have our list view. Here we also have a model, in this case, a JSON list model, which can take in JSON data and present it for the view. And what we do here is we just use some properties from the data model. So the view does not actually cover any fetching of the data. It just refers to the data and uses it. On the other hand, in our main file, we use the data model to fetch the data And the data model itself covers all of my application state. For example, it has a read-only property whether the API that I'm fetching the data from is currently busy. It can hold the login state, whether some user is currently logged in or not. It can provide data for the views. Yeah, and also the functions to retrieve data, store data, log in or log out, things like that. Which means that regardless of which page I'm working on, regardless of how many options I have, for example, to create and store such a to-do, like in this example, each and every page goes through the same API, which is provided by the data model. So I do not have any duplicate code here. I do not have code completion. Also, I can switch the user interface to a different implementation, for example, on different screens or platforms, and still have all of my functionality and all of my properties, my states, whether a user is logged in or not, managed in the data model and ready to be reused by the user interface. The last topic is also quite interesting, and it's QML Hot Reload, which is a tool to develop and test QML efficiently. If you look at your development process, you usually code something, you save your code, you compile it, you deploy it to your test devices, and you test it, see what works and what not, then jump back into coding. And this iteration is always going on. If we look at the compilation and deployment step, this usually takes a really long time. So you have to wait for 10 seconds or maybe up to 5 minutes, depending on what platform you're building your application for, until all of the compilation and the deployment is finished. We do this for every change and also for multiple devices. If we want to support Windows and macOS and maybe also mobile clients or embedded devices, we need to test our code on each and every one of them. And all of this testing multiple times a day on multiple devices, always for several minutes or at least 10 seconds or 20 seconds, stacks up a lot. And with the Felgo QML Hot Reload tool, you can reduce this time to 2 seconds. How does it work? As QML is such a flexible language, and it's actually interpreted and compiled at runtime by the QML engine, we can also apply QML code changes at runtime. We do not actually need the compilation and the deployment step, which means it's possible to just change your code, hit save, and then directly reload your code in your running application and see your changes without ever having to build and deploy. The Hot Reload tool is a standalone tool for Qt projects, so you do not have to use, for example, the components that you saw before from the Felgo SDK, like the navigation or the navigation stack. You can use it with any plain Qt project. To grab it, just download the Felgo SDK, and you will find the QML Hot Reload tool along with the Felgo installation. You can also use it to test on multiple devices simultaneously. So if you're developing on desktop, you can have the Hot Reload on desktop, but you can also connect external hardware or a mobile client, and yeah, basically instantly see the changes that you make on all of the devices at once. This really speeds up development and is a huge boost, especially for UI development, where you need to do a lot of UI testing, user experience testing, and so on. So yeah, let's see how it works. I'm again in the test project from before. As I'm here on the Felgo installation, I can just hit the live run button. But as said, you can use the tool with any Qt project. If you have downloaded the Felgo SDK, you can also start the tool from the command line. and just pass the directory where your project is located. And then the Felgo Live server will open up for your project. And you can just hit the start button to open the Felgo Live client, which is now displaying your application. Yeah, so what can we do here? Let's see. We have everything set up, everything running. Now I can start changing my code. For example, I could add another navigation item, which is actually this tab at the bottom. And save. And you already see we got a second tab now that I can open up. I can add a title to the page. Now we see we produced an error with the brackets. Save again. Now it's here. Change back. Hello world. Hit save. And we have a title. Then, yeah, I can create a button, use the positioning and centering mechanisms, and save the code. Add some text. And here it is. I can also click the button, but nothing happens yet, obviously. So let's add a click handler. Have some test output. Now, if I look at the live server and I click the button, I can see I get my test output now here. This is required because I did not build and run my application, so I cannot get the log output directly. Instead, the live client sends all of the log output to the live server, where you can then see it. Now, we also said we can test on multiple devices at once. So I have my iPhone here. And here I have the Felgo Dev app pre-installed. You can also create a similar live client for your own application, or use the Felgo Dev app from the App Store. Sending the connection requests. And now you can see I'm connected also on the phone. Switch to the second tab. Click the button, and I can also see, also from my phone, I immediately get the log output similar to the desktop. So let's do some more development. What shall we do? Let's change the text to clicked after we clicked it. Or we can add another button. Both of them in a row. Another click handler, and change the tint color to green, let's say, just as an example. So again, so let's type that one. Yeah. Yeah, as you can see, it's really, really fast to develop a user interface this way. I do not have to build, I do not have to compile. I can just keep on coding and updating my application. In addition, if you also use the model view separation as an architecture, it really is easy to change the UI components, add new tabs and things like that, without affecting the application data. And yeah, you can optimize the application and the user experience in a really efficient way and really fast. That's it for the QML Hot Reload live demo. Yeah, if this got you interested, or if you have some problems in your project, you can always reach out to us for anything Qt related. Felgo is a Qt technology partner and also Qt service partner. And our focus is really to help you in your projects to achieve your goals. And if especially the QML training for the architecture and QML Hot Reload and how to make the most out of Qt Quick got you hooked, then I encourage you to check out our Qt trainings and workshops, where we also have a dedicated training, which is a whole day just for that topic. And yeah, I'm happy to take your questions now.